So for Unit 2, we are doing a little activity. I'm calling it an activity. You might call it like a project or, a worksheet or something like that. So I'm just calling it an activity because it's not like a timed assessment. Um, the whole purpose of doing this in this way, where you have to show your work and stuff, is just so I can see your thought process, and that way I can give you a more accurate grade. So your grade will be a more accurate reflection of what you know, rather than just a multiple choice, like you get it wrong or you get it right. So just some details about this activity and how it'll work. You have to work alone on this activity, but you may use the guided notes and our lecture videos as well as this video. So any of our course resources you are allowed to use. I don't want you using any outside resources aside from what I've given you in the course. You can ask me questions. It'll be, over the weekend, but you feel free to email me and I'll keep my phone close by so I can try to get back to you quickly. And the most important thing, you must show all work to receive full credit. So that's the whole purpose of this activity, is me being able to see your work. So you have to show all of your work to receive full credit. So basically, I don't want to see something like this, and where I'm asking you to evaluate an expression, and then you just write like 12 equals 12. All right, so I want to see your actual work. I want to see your thought process. It doesn't have to be, you don't have to show me every step, but I should be able to figure out how you got from, the beginning of the problem to the answer. All right, so this activity covers evaluating expressions and factoring. And within the evaluating expressions part, you're going to see questions about evaluating expressions, solving equations, and you'll also see factoring. So factoring numbers, finding the greatest common factor of two numbers, two or three numbers, and then finding the greatest common factor of an expression. And then we will look at factoring some basic trinomials. All right, so that's sort of an overview of what the exam will cover. All right, so starting at the beginning with evaluating expressions, it says, oh, and I just made these up. I just made these up off the top of my head yesterday. So I just looked at the test, or at the activity, excuse me, and I chose similar questions and I just changed the numbers. So that's where these questions are coming from. They're not like in a document anywhere. I just made these up yesterday. All right, so evaluate the expression for a equals 5, b equals -8, and c equals 12. All right, so if you want to take a second and write this down and work it along with me, you can. I'll try to go slowly. All right, so evaluate the expression for a equals 5, b is -8, and c is 12. All right, so we have -2b plus 3a times 7c. All right, so we are going to start plugging in our numbers. B is -8, so that's going to be -2 times -8 plus 3 times A times 7 times C. All right, so 3 times A was 5, times 7, right, that's coming from right there, times C, which is 12. All right, so now we're just doing order of operations from here. So we will plug in the values, then use GEMS or PEMDAS. Whoops, that's a B, not a P. PEMDAS. Okay. So we're going to do order of operations. We don't have any grouping symbols. We don't have any exponents, but we do have some multiplication and some addition. All right, so we have multiplication here, and then all of these are being multiplied. So we need to go ahead and simplify those chunks. All right, -2 times -8 is +16, then plus 3 times 5 is 15, times 7 is 105, times 12 is 1260.
Ooh.
Yeah, that's a big one. 3 times 5 times 7 times 12 is 1260. You can tell I just made this up because these are not good numbers. All right, and then we're going to add that to the 16 to 1276. Now, you could, let me pull this up on the calculator and show you. You could plug that whole line into the calculator. I'm not sure that I would recommend doing it that way, but you could. Right, so you could do, let's see, -2 times -8. So -2 times -8 plus 3 times 5 times 7 times 12. So you could plug all that into the calculator at that point. Just be careful. That could be a way that you check your answer.
12 times 5, Cadence. Nope. Gabby, 12 times 5.
All right, so evaluating expressions. I did one of each type. So here we have just a normal expression with multiplication and addition. Here's one with a fraction. I just wanted to show you a couple of different types of problems. All right, so here we have -2a plus c over 6b minus 4a. Here a is 5, b is -8, c is 12. I think I used the same values. Yeah.
12 times 3.
So that's -2 times 5 plus c, which is 12,
12 times 3.
over
36.
6b, so 6 times -8,
12 times
minus 4 times a, which is 5.
2 times 12.
All right, so the advice I gave you in the video, if you've watched it, is to, let me see if I can,
12 times 6.
it don't matter, is to just look at each piece separately. So start by looking at the numerator and simplify that. And then once you've got that simplified, go to the bottom, simplify the denominator. All right, and then once you've simplified the denominator, put it all together. All right, so I'm just going to look at the numerator for right now. So I'm looking here.
2 over -68.
2 over -68.
Was that right?
-10 plus 12. Yep, so that's, the top is definitely 2. The bottom is -48 minus 20. So yeah, -68. And then that would reduce because 2 goes into both of those. So that would become 1 over
-34.
34.
Not the
I
best at
chose
these.
better answers out for the activity, I'm pretty sure. But I know there is somewhere the answer is a fraction. Okay. So evaluating expressions, just plugging in the numbers and then using order of operations to simplify. All right, so here's the one that's on the activity that Natasha was saying was confusing. So
Yeah.
on the activity, the directions are solved for X. Here I'm going to do Y, but it's going to be very similar. What you're going to do is going to be very similar. All right, so we have F equals G times XY over R squared. Now, don't let the R squared mess you up. Right now, think of it as we have a fraction right here, and right now this G is in the way. So we need to get rid of the G first. So go ahead and divide both sides by G.
Oh, Jesus.
Yep, then that's going to cancel out G. Cancel, cancel.
Gabby, you first.
Then you have F over G equals XY over R squared.
On the top left, okay? I'm going to read the problem.
All right, so we're a little bit closer. We've gotten rid of the G. Now we're just left with this fraction. You could cross multiply here. I'm not sure that it would help you all that much. But I know that is some people's like first instinct is when they see a fraction equal to a fraction, they want to cross multiply. So you can do that. So you can cross multiply if you want. So at this point, you can cross multiply if you want. I don't think I'm going to. But again, if that's your preferred method, that's fine. All right, so what I'm going to do is I'm saying, okay, well, I'm trying to get this y right here by itself. So right now, what's standing in my way is this r squared. It's in the denominator, so I can move it over. I can get rid of it by multiplying both sides by the denominator. All right, so I'm multiplying both sides by r squared. That's going to cancel it over here. That's going to get rid of my fraction. All right, on the left-hand side, I'm going to have r squared times f over g equals x, y. I've almost got y by itself. All right, so the only thing left standing in my way is this x. All right, and I'm going to divide the whole thing by x. Do the same thing over here. Cancel, cancel. So I get y equals r squared times f over g, all divided by x. Right now, y is by itself, so I know I'm done. That's my answer. Now, you could make this look nicer if you wanted to. You don't have to.
Okay, just hold it for just 1 second.
Okay.
Yeah, that one confused a little bit.
Yeah.
This is my problem. Like, I don't know when to stop.
Yeah,
I just keep.
Sometimes you'll go back so far in a circle, you'll end up back at the beginning. Like, how
That's
did
what
this
that
happen?
kind of looks like.
Yeah. So you can make this left-hand side look better. It just doesn't matter. I didn't ask you to write it in simplest form or anything like that. So if you
I would
were
look at
gonna
I would look at this and thought I did something wrong.
yeah. Because it looks worse than what you started with.
Yeah,
Um,
I don't get it. It's the only question on my thing that I don't get, and I feel like I don't know. I don't get.
Where do you feel like
I
you
don't
lost it? Like,
get it.
were you
Like,
good when we divided by g at the beginning?
To
because
me, it was the
okay,
R2 thing.
Okay.
the I get okay. So up until multiplying by r squared times f over g equals xy over r squared. Then you multiplied both sides by r squared, which canceled that r squared from the bottom. So now you're left with r squared times f over g equals x, y.
Mm-hmm.
And then I'm lost.
Okay. Okay. Let's see.
Is it in the thousands place, hundreds place? The 3 in that number.
Okay. Do this. X, Y. Okay. So we can make this look a little bit nicer by saying, okay, well, that's like a fraction to r squared over 1. You can make this into one big fraction and say that it's r squared times f over 1 times g is just g. Okay. Now, over here on the right-hand side, over here, the only thing that we've got going on over here is x times y. All right, so you've got to get y by itself. That's what we're supposed to be doing. All right, so we've got x times y, so we've got to do the opposite operation. Right now it's being multiplied, so we're going to divide. Now, on the activity, you're trying to get x by itself, so you would divide both sides by y. But here, we're asked to get y by itself. Well, I don't know why it's not right. There we go. We're asked to solve for y, so I'm trying to get y by itself. So I'm going to divide both sides by x to get rid of that x. Cancel, cancel.
Out your answer. Where with the 3 in the very end?
Right. Cancel, cancel. That just canceled out.
So
Then I
Rx and R squared.
r squared times f over g over x
Oh my goodness.
equals y. Now, this is like the big fraction, so maybe I'll try to make this one bigger.
When I say place, where is the 3? We have the 3 is the very right.
But don't let the, the complicated way that it looks, don't let that mess you up. Your only goal here was to get y by itself, and you've done that. So you're done.
So for I don't know, that's not the way I did the one I did.
That's okay. If it should look somewhat similar, it doesn't have to look exactly the same. Let me show you. You might like it better if I cross multiply. So let me try that.
Is my answer for the? I just want to know if it's right or not. Well, I know. I don't think you. I don't expect you to tell me that. So that's not fair.
Yeah.
But I don't know. So how I did it, because I essentially should get something that looked like what you just got.
Somewhat similar, but it could be simplified, so it may look different. Let me show you the way I'm going to do it this time and see if yours maybe looks similar.
Okay.
All right, so if you were to cross multiply, you're just going to multiply across the equal sign. So that becomes r squared times f. So r squared times f equals g times xy. So g times xy. All right, now you're trying to get y by itself. So you're trying to get y by itself.
Mm-hmm.
Now, over here, we've got g times x times y. So we can divide by g times x.
Right.
And that's going to cancel, cancel. Then y is by itself. And then we have r squared times f over g times x. Now, does that look something like what you had?
Yes, it does.
Okay. Good.
But I put FR squared instead of R squared F.
Oh, that's fine. Yeah.
That's
as long
fine.
since it's
Okay.
multiplication, that'd be like 2 times 3 is the same as 3 times 2.
Okay.
So that's fine. Well, good.
Okay.
That makes me feel better.
All right. Because
Short division,
okay.
long division, whatever you call division.
Yeah, I think the cross multiplication actually was a little bit easier in this case.
Yeah. That works for me. That works
Okay,
for me.
cool. All right, so here I did one that was a little bit easier. Solve for t. V equals d over t. This is velocity equals distance over time. So if we're trying to get t by itself, you can get t out of the denominator by multiplying both sides by t. So times t.
Yeah, that one was a little challenging for me too, but I figured it out.
Yeah. Cancel, cancel. Then over here we have t times v, or you could do v times t, whatever you want. And then equals d. Now I'm trying to get t by itself, so I'm going to get rid of this v. So I'm going to divide both sides by v. Cancel. So t equals d over b. So if you have a fraction, you need to get something out of the denominator. The approach is to multiply both sides by the denominator. That's a very common approach for solving for a particular variable. Okay. GCF. Now, you probably learned this in Math 2008, but I thought it may have been a while, so I wanted to refresh your memory. So if you're finding the greatest common factor of 2 or more numbers. I like to use a factor tree. There's different ways that you can do it, but this is my preferred way. So I go in and I make a factor tree for each number. And here you can start off any way you want. For 8, there's only, 2 factors or 2 things that multiply to give you 8 besides 1 and 8. You would use 4 and 2. But for 12, you could start with 6 and 2, or you could start with 4 and 3. Either way would be fine. All right, so for 8, we broke that down into 4 times 2. 4 gets broken down into 2 times 2. All right, and then from there, 2 is prime. So 2, 2, 2, those are all prime. So my prime factorization would be 2 times 2 times 2. So that's all your primes. All right, then we do the same thing for 12. I'm going to do 6 times 2. 6 could be broken into 3 times 2. All right, 3 and 2 are prime, so I'm down to my prime numbers, 3, 2, and 2. So we'll say 12 equals, we'll go in smallest to biggest, so 2 times 2 times 3. All right, so 2 times 2 times 3 is the prime factorization. And then for 20, we could do 10 and 2, or we could do 5 and 4. Either way would be fine. I think I'm going to do 5 and 4. Then 4 gets broken down into 2 times 2. 5 is prime, 2 is prime, so I am in my prime factorization. So 20 is 2 times 2 times 5. All right, then to find the greatest common factor, you look and see what do all of those prime factorizations have in common. So the greatest common factor is going to be, look at these prime factorizations and see what do they have in common. They all have a 2, and they all have another 2. All right, so that's going to be your prime factorization is 2 times 2. This one has another 2, but the other 2 don't have an extra 2, so we can't count that one. This one has a 3. The other 2 factorizations don't have a 3, so that doesn't become part of our GCF. And then this one has a 5, but the other 2 factorizations don't have a 5, so that is not in common, so it's not part of our factorization or our greatest common factor. All right, so then last thing you do is just multiply the prime numbers together to get your greatest common factor. All right, so greatest common factor here is 4. All right, so there will be one like this on the test. I want to say there, or not the activity, not the test, the activity. I think I have somewhere. Yes, number 5 and number 6 are greatest common factor problems. And then also number 8 is a greatest common factor problem where I'm showing you some work and I want you to try to find the mistake. All right, so you'll have 3 of these problems, 3 problems like this on the activity. All right, now here we have a factor out the GCF. All right, so when you see those directions, oops. Is that okay? Yeah. Okay. Factor out the GCF. That means figure out what the greatest common factor is, put it out front. So then you'll put it out front right here, and then we'll put in parentheses the stuff that's left over once we divide by the greatest common factor. All right, so you're going to start by looking at your expression. So we've got 10x squared y z squared. All right, so 10x squared y z squared minus 6xyz squared plus 18x squared y squared z. All right, so this is similar to number 7 part D on the activity. So you're going to start by looking at your numbers 10, 6, and 18. What number goes into 10, 6, and 18? What's the greatest common factor?
Take a look at the first
2.
number first.
Yep, 2 goes into all of those. All right, then you're going to say, okay, what do all the variable portions have in common? So they all have an X, they all have a Y, they all have a Z. X, Y, Z, X, Y, Z. Yes. All right. So let's go through individually. This one has 2 X's. Does this one have 2 X's? No, it does not. So it only has 1 X in common so far. What about Y's? Here, 1 Y, 1 Y. This one has 2 Y's. All right. They only have 1 Y in common. And then Z, we have Z squared, but this one only has 1 Z. So we're only pulling out 1 Z. So we're going to pull out an X, a Y, and a Z from each term. All right, so we're going to go through and divide by the greatest common factor. So 10 over 2 is 5. X squared, cancel out 1 X, you're left with just an X. Y, cancel out Y, Y's are gone. Z squared, cancel out 1 Z, you're left with just 1 Z. Minus 6 divided by 2 is 3. X cancels out, Y cancels out, Z, one of the Z's cancels out, so 1 Z is left. Plus 18 over 2 is 9. Right, just looking right here, we're canceling out one of the X's, one of the Y's, Z goes away. So X and Y are left over. And that's it. All right, so you're just identifying what is the greatest common factor. Once you've got that, you just put that out, put the greatest common factor out front, and then divide each term by that greatest common factor. All right. Factoring by grouping. You're gonna know on the activity because it tells you specifically on number 9. It says hint, use factoring by grouping. So you're gonna know when to do this. This is number 9. This is number 9 on the Unit 2 activity. But anytime you see a expression that has 4 terms, that's sort of your clue that you need to do factoring by grouping. All right, so I always just start by grouping the first 2 and the second 2. You should check first to see if there's a greatest common factor for every term. We have 6, 3, 8, and 4. Nothing goes into all of those. The 3 kind of messes it up. So now we know that since there's no greatest common factor between all of them, we're just going to look at the first 2 and the second 2. All right, you're starting by just looking at the first 2. So we're just looking over here on the left. And we're saying, okay, 6x cubed and 3x squared. Well, they both are divisible by 3. So that's part of the greatest common factor. And they both have an x squared in them. So we're going to factor out a 3x squared. Then you're going to divide through by that. 6 over 3 is 2. 3 x's take away 2, leaves us with 1x. Plus 3 over 3 is 1. We don't have to write the 1. But you can. All right, and then x squared, take away 2. Let me say that again. 3x squared over 3x squared is 1. All right, so the numbers canceled out and the variable canceled out, so all that's left is 1. All right, now looking at the second 2, 8x plus 4. 4 goes into both of those, and we don't want to write just 4. You want to make sure and indicate that it's positive. So you indicate that it's a positive 4 that you're taking out. So if you divide by 4, 8x becomes 2x. 4 divided by 4 is positive 1. All right, then you're going to check and make sure that your stuff inside your parentheses matches, and it does. So the 2x plus 1 matches with the 2x plus 1. All right, then that common factor gets pulled out front. And then in the second set of parentheses, you're going to put the leftover stuff. So that's 3x squared plus 4. 3x squared plus 4. All right, so factoring by grouping, I want to say it's like a 6-step process, the way I described it in our notes. But you start by grouping the first 2, group the second 2. Just look at the first 2, pull out the common factor. Then look at the second 2, pull out the common factor. Make sure your parentheses match. Bring that common factor out front. Put the leftover stuff in the second set of parentheses.
I was a little scared of this in the beginning, but after I went through the video last
Yeah.
night, it was fairly easy.
Yeah, and it's like the same every time, so you kind of like develop this like pattern in your mind.
I think this is just going to take some
Right.
practice for me.
Yeah. Yeah, it definitely, the more you practice it, the easier it's going to get, and you'll be able to do it really quickly. All right, let's do one more. Factoring by grouping. I think I just did one more. Yeah. All right, so this one, let me see. I don't think it's a lot more difficult than the last one. This is definitely harder than what you're going to see on the activity, if that makes you feel better. You want to start by looking at each term. -15, -30, 5, and 10. Those do have a common factor of 5. We can go ahead and pull that out. So every once in a while, this will happen where you end up getting everything has a common factor. So if we divide everything by 5, that would be, actually, let's do -5 so we can make this first one positive. That'll make everything easier. All right, so if we're dividing out by -5, that's going to become 3x squared y. -30 over -5 is positive 6xy squared. Positive 5 divided by -5 is -1xy. Positive 10 over -5 is -2y squared. Okay. Now you're going to just do factoring by grouping like normal. You're going to look at the first two, then look at the second two, and then pull out a common factor. All right, so the -5 is just going to get dropped down every time. And you didn't have to do -5. If you would have preferred to do positive 5, that would have been fine. The negative will get taken care of either way. All right, so just looking at the first two, they both are divisible by 3, and they both have an x, and they both have a y. So I'm going to pull out, I'm going to make this a big parentheses. Then I'm going to pull out a 3xy. So what's left over here would be x. Here it would be 2 and a y. So here I'm just dividing by 3xy. Right now I'm looking at these two. They both have a y in common, and they're both negative. So we should pull out a negative y, parentheses. Negative divided by negative makes it a positive x. Try that again. Positive x. There we go. Well, no. You just erase it and start over. Okay. Positive x. -2y squared divided by -y. That turns it into a positive. And the 2 is left, and one of the y's is left. Okay. Close that big parentheses. Okay. Now, we're just proceeding like normal. We're making sure the stuff inside the parentheses matches. It does. Right, then we're going to continue on. We just drop down the -5. We're going to pull that common factor out front. So x plus 2y. Right, then in the second set, you're going to put the leftover stuff. So 3xy minus y.
So
Now,
Dr. Berry, for this
Yeah.
one, it seems to me a little different because would it still be the same if I had just done the two sections separately from the very beginning
yes,
without doing the -5 at the front?
you would, but you would get the same answer. But what's going to happen is what just happened here. So notice now that like 3xy minus y, those both have a y in it. So now we got to pull out the y. So it's not technically fully factored until we get all the common factors out. This one has a common factor of y. So that has to get pulled out. So that becomes 3x minus 1. Right. And then now we can just rewrite this. This is all multiplication. So you can think of it as like 3 times 2 times 5. We can rewrite that as 5 times 2 times 3. All right, so you can rearrange the order since it's all multiplication. And that's what I'm going to do here. I'm just going to rearrange the order so it looks a little bit neater. I'm going to do -5 times y times x plus 2y times 3x minus 1. So yeah, Natasha, from the beginning, if you just want to group them 2 and 2, that's fine. But you may end up at the end having to pull out a common factor on the very last step, which is fine.
Okay.
But like I said, this one is much harder than what you're going to see on the activity. I just randomly grabbed this one off the internet. I didn't realize it was a tricky one like this. All right, so don't let this one scare you. It's harder than most of the other ones.
That's a 3.
Now, the part that I felt like people would be the most nervous about, or maybe just the most out of practice with, is the factoring trinomials portion. So I tried to show you a method so that you could do it the same way every time, which was to make that little table. And I really like this table. I've taught factoring a lot of different ways over the past 10 years, and this is the one that I always come back to. I think that it's the easiest to use. So I always make this little table, pairs of factors, sums of factors. Now, the more you do this, you might not have to make the table every time. You might get so good at this that you can do it in your head. So just think of this as like a way to help you get started, but don't feel like you're married to it. You don't have to do it. All right, so you always want to make this little table and then start by setting up your little template. So it's going to be x plus blank, x plus blank. Now, the blanks are what we need to find. We need to figure out what are the numbers that go in these blanks. And we're going to do that by using the table. All right, so the table is going to help us figure out what numbers go there. The way that we factor is the numbers have to multiply to give you this last term, and they need to add to give you the middle term. So we're looking for numbers that multiply to 12, but add to 7. So what are some numbers that multiply to give you 12?
6 and 2.
6 and 2. 1
3
and
and
12.
4.
4 and 3, yeah.
Eva, be careful.
That's it.
7
Right? Yeah. So now we're going to add those up. 6 plus 2 is 8. 1 plus 12 is 13. 4 plus 3 is 7. 7 is the number we're looking for. So that tells us those are the numbers.
4 and 3.
And that's what goes in the blanks.
I'm sorry.
I love the singing in the background.
I'm sorry, Eva, I think
We're getting ready. I might have to jump off in 2 minutes. We're getting ready to go.
Okay. All right, so use this method. I really think it's helpful. And I think that if you do this the same way every time, it's going to get like burned into your brain and you're going to remember how to do it. All right, so here's one that's a little bit more complicated because it's got a negative number. All right, so remember how we do this. We start by writing our little template. We say x plus blank, x plus blank. Then we come over here, we make our table. Pairs of factors, sums of factors. All right, so things that multiply to give you negative 63. Remember, they're supposed to multiply to give you the last number and add to give you the middle number. So they're supposed to add to 2. So multiply to give you negative 63 and add to 2. All right, so things that multiply to give you negative 63. Oh yeah, 9 and 7. I was thinking 2 is divisible by 63 also. No, it's not. It is divisible by 3. 21 and 3. One of them's got to be negative. It's got to multiply to give you negative 63. So we'll do negative 21 and 3, positive 21 and negative 3. I just remembered 9 and 7. So we'll do negative 9, positive 7, and then positive 9 and negative 7. And then, of course, negative 1 and 63 and positive 1 and negative 63. So I'm just writing everything I think of, and then I go ahead and start adding them.
I'm going to go ahead and jump off. I'll catch the rest of the video in the link. Thank you so much.
Sounds good. Thank you.
Bye.
So now I'm just adding these together. So negative 21 plus 3 is negative 21 plus 3. Whoops. Negative 18. 21 plus a negative 3. 21 plus a negative 3. That's the same thing as saying 21 minus 3, which is positive 18. Negative 9 plus 7 is negative 2. 9 plus negative 7 is positive 2. That's what we're looking for. All right, so now we found our numbers. All right, now we go in here and we fill them in, 9 and negative 7. And then the only thing I do want you to do here is anytime you have a plus and negative, I want you to simplify that. So that becomes x plus 9. That stayed the same. Plus a negative is the same thing as a minus. So just change that to minus. You're done. Now you can multiply it back out if you want to check your answer. So that's the good thing about these, is that even though they are tough, you can check your answer. And once you find the answer, you don't have to finish filling in the table. Right? So once you find the right number, you don't have to finish filling in the table. All right, so I tried to choose one of each type. Here we had a plus and a plus. Here we have a plus and a minus. So this one is a minus and a plus. All right, but they're all done the same way. So you start out, you do your little template, x plus blank, x plus blank. Make your table. Pairs of factors, sums of factors. Okay. And here in this case, they are supposed to be multiplying to give you 3. So multiply to give you 3, and they need to add to negative 4. Okay, so multiply to give you 3, add to negative 4. All right, so 3 doesn't have a lot of factors, so this should be pretty quick. The only things that multiply to give you 3 are 3 and 1, and also negative 3 times negative 1. All right, so negative 3 times negative 1 is also negative 3. All right, so if we add those together, 3 plus 1 is 4. All right, so again, I'm just adding these together. Negative 3 plus negative 1, that's the same thing as negative 3 minus 1 is negative 4. That's the number we're looking for. So those are our factors. Those are our factors. So that's negative 3, positive, negative 1. Negative 3 and negative 1. All right, so I do need to simplify that. So that becomes x minus 3 times x minus 1. Okay, and then our last one, we've considered 3 cases. The only one we haven't done is where we have a minus and a minus. I think that's what I did here. All right, so you're going to do it the same way. Set up your template. So this one's x squared minus 2x minus 35. Down here, you do your table. Pairs of factors, just abbreviating that, sums of factors. Right, and these factors are supposed to multiply to give you negative 35, and they need to add to give you negative 2. 35 does not have a lot of factors, just one in itself. So negative 1 times 35, or positive 1 and negative 35. And also 7 and 5. So let's do 7 and negative 5, and then negative 7, positive 5. Okay, so now we're just going to add those together. That's always in my way. All right, so I'm going to add these together. All right, so -1 plus 35 is 34. 1 minus 35 is -34. 7 minus 2 is, or excuse me, 7 minus 5 is 2. And then -7 plus 5 is -2. And that's what we were looking for. So that's our factors, -7 and 5. And then just simplify that plus a negative. You'll be done. Okay. All right, so the activity is already up. You may turn it in as soon as you want, or you can, like I said, you have until, let's see, I've got the details over here. Let me show you. It is due by Sunday, June 30th. That is this Sunday. By 11:59 p.m. And then I did just add a little bit of some details up here. You may not work with anyone else on this assignment. If I find that you've been working with a classmate, tutor, or other person on this assignment, you will get a 0 for the activity, and then I'll have to submit documentation of an academic integrity violation to the behavioral intervention team. And like I said at the beginning, it's very important that you show all of your work so that I can give you the maximum credit. And like I said, you can turn this in as early or as late as you want to, just as long as you get it done by Sunday, June 30th by 11:59 p.m. All right, so let me stop sharing. Well, and now I'm lost.
If we're struggling with one, we can email you and ask you questions, right, about this or no?
It lost me again. All right, but I'm back. Okay, so I think it just stopped the recording. Hopefully that whole thing was recording. I'm not sure, but anyway,
If we're
If it
struggling
wasn't-
on something with this, can we email you and ask you a question?
absolutely, yes,
Okay.
yes,
All right.
yeah. Just let me know, and I'll be happy to help you.
Okay.
All right, I'll see you in a couple of weeks.
Thank you.
You're welcome. Bye.